On this beautiful day, we're going to look at surface areas of prisms and cylinders. Prisms and cylinders. So, of course, those are our goals. By way of definition, it's a prism and a cylinder are two-dimensional objects that start off as one dimension. So just take a square, for example, or a rectangle. And if you were just to be able to pull this thing, pull it across, and make a solid, that's what a prism is. And the same thing with a cylinder. So if I have a circle here, and I drag the circle down, and just so it fills in, now I've made a cylinder. So that's one way to define three-dimensional objects. You take a two-dimensional object and just stack it on itself. And so that's what we'll be chatting about here. So notice here, each one of these has its own name, and what makes it a prism is that it's the same shape, a hexagon, just stacked on itself until it comes to an end here. And here is a pentagon stacked on itself until it finishes there. All right, so by way of definition, bases. Bases are always parallel. That's the most important part about prisms. The bases have to be parallel. So in this hexagonal situation, here is a base, and of course, there's the base on the other end. Remember, base does not mean bottom. And some of you might say, but wait, Swenson, look, this top here and this bottom here are parallel. Aren't they going to be bases? And the situation with these ones is that these ones are all rectangles going all the way around, and these ones are all rectangles going all the way around. So in certain prisms, what we call the lateral faces. The lateral faces are the faces that connect the bases. They connect the bases. And those are oftentimes going to be rectangles. This one's unusual, because how do we know what the base is? How do we know what a base is? Now, this one has a highlighted. In mine, it's highlighted. So it seems like this could be a base and this could be a base. But in this case, we have multiple bases. We have multiple bases. When I say multiple bases, it's sort of a perspective. If you wanted to call the bottom and the top the bases, you have that freedom. If you wanted to call the left and the right, you could have called those bases. Or I could have called the front and the back the bases. And whatever the shape of the base is, that's the name of the prism. So in this case, we have a hexagon as a base, so we call it a hexagonal prism. Same thing, a pentagonal prism, etc. The height is the distance between the bases. And BT means between bases. A right prism is where your lateral faces are perpendicular to the base. If your lateral faces are perpendicular to the base, we call that a right prism. However, if your lateral is not perpendicular to the base, we call that oblique. We call that oblique. And so here would be an example of a right prism, just going straight back, and or if I stood this on end like a Pringles can, but not a cylinder, then it would be the one base would be directly above the other base. In this case here, notice that this base here is not perfectly above this one, so in this case, oblique is what we have. All right, so the first thing we want to talk about is surface area. And this would be just the sum of the areas of the faces, of all the faces. Of all the faces. And we're often going to see it spoken of as, the term lateral area, which means the area of the non-bases. of the non-bases. In other words, all the faces that connect the bases. All right, so surface area of a right prism. It's going to be this here. If there's two components, you have two bases, so we're going to say capital B for the area of a base, plus we're going to add the lateral area. So let's just make sure we have the terms here. B is area of base. And of course, this could change. If the base is a rectangle, you use one formula. If the base is a hexagon, then you're going to have to use a different formula. And then lastly, what does LA mean? LA, of course, means the lateral area. If you remember in the MCAS or any of the formula sheets that we've given to you, notice here it talks about the lateral surface area, and so it tells you what things are. When you have a right rectangular prism, you're going to say the height, 2 height times the width plus 2L times H. So this does get sort of complicated as you're breaking down each lateral area of what that shape is. So we'll help you unpack those as we go. All right, and also while we're here, let's go ahead and tap on what lateral area often will be. It's going to be the perimeter of a base times the height of the diagram. So P means, in this case, perimeter of base. And H, this H, is the height of the solid. So there's going to be some confusion here, and my apologies for it, but there's so much going on that we have to watch out. So say, for example, I have a rectangle here. You don't have to write this down, but oftentimes we'll say, oh, base times height, and then we say, so the area of this is B times H. But what if I had a three-dimensional shape made from the shape I just made? So, well, it turns out that we have an area of this thing right here, but we also have this distance right there. And that distance is also called H. Why? Because it's the height of my prism. Over here, I'm talking about a two-dimensional object, and sometimes we say length, length and width. Sometimes we say base and height. And so here some confusion can come out because the height of one object is not the height of the other object. So we just have to watch out we have to keep things in our own categories. Height over here is applying to a two-dimensional object. Height over here is a three-dimensional object. Okay, so let's walk through and see what we have here. Okay, in this first diagram here, I need to select my bases, okay? Now, I did forget to mention, let me be more clear about bases. Bases are also congruent, so my apologies. So they're congruent and parallel. So in this, what looks like a box, I have options. Now, I like to just select the bottom and the top when I can, because visually it's easier for me. But of course, don't always get stuck in that rut. So if these are my bases right here, I need to find a couple things out. Number one, I need to find the area of the bases. Then number two, I need to find the area, the lateral area. And of course, my formula is going to be the surface area of the prism is going to be 2B plus the LA. So I'm starting with that, and I have to add them all up. Now, what do we mean by the lateral area? Of course, the lateral area is this front face, the right face, the back face, and the left face. So it's all of those combined. Well, if you were to unfold the box, and I'm not going to draw it to scale here, and you don't need to draw it right now. This can be a net of the diagram. And this is the base, and this is the base. But notice what this shape is right here. This is a very, very large rectangle. So I just have whatever this height is right here times all the way across. And notice what from here all the way to here is. It's the distance around the base, which is why we say the P for the lateral area, PH, perimeter of the base. Why? Because this whole rectangle wraps around that there. So all of this, all the way across, is your P, and this right here is your H, the height of the box. So this holds true for all prisms. So we're finding the area of the bases and then the area of this big thing right here, just by saying, oh, what's the perimeter? What's the perimeter? And multiplying by the height of the object. All right, so the area of this base here, no big deal. We just need to see, oh, it's 6 times 12. We're just using length times width or base times height. So in this case, 6 times 12. And so we get 72 square inches. Next up, I need to find out what the perimeter and the height is. The perimeter is 12 plus 6 plus 12 plus 6. So I'll write that down so we can see, but 12 plus 6 plus 12 plus 6. Now there's other ways to do that. Of course, you could just say 2 times L plus 2 times W, but I'll just add them up here because that one always will work, just add up all the way around. And of course, the height is the distance between the bases. The height is the distance between the bases. So my bases I colored as red here, so the height is that distance there. So all of this simplifies to 288 inches squared. Now, of course, we're not done, and that's the problem, is that we've got so many different components. I found the area of one base. I found the area of all the lateral area. So now when we combine it, bring it all together, we say this: the surface area of the entire thing is 2 times the area of my base, which is 72, plus my lateral, which is 288, 432 square inches. Okay, so we have to watch out. The base, when I'm talking about a base of a three-dimensional object, I'm talking about a polygon. So in this case, the base has to be the front and the back. The front and the back triangle. So because it's a triangle, the area of the base is 1/2 a different base, a different height. Okay? So in this case, the area of the base is going to be 4 times 3. So again, I apologize. When I say base versus base, they're small. One's a capital B, one's a lowercase b. All right, so now here, real quick, I see that I end up with 6 square inches for the area of the base. Now the lateral area is the sum of the 3 rectangles, the slanted one, the vertical one, and the horizontal one. Now, of course, that's still the exact same formula. It's still the perimeter of the base times the height of the shape. So this guy here has to be the height there. Again, let's not confuse it, the height of my base versus the height of the solid. All right, and so here, what's my dilemma with finding P? So in this base right here, I have a side 3, a side 4, but I am missing this side there, in this case, the hypotenuse. So in order for me to find that, I do have to take a moment to do Pythagorean theorem. Now, some of you might know that this is a special triangle already. Not a special right triangle, but it's a 3, 4, 5 Pythagorean triple. If you forgot that, then simply we can just say x squared is equal to 3 squared plus 4 squared. And then when you simplify all that, x is going to be 5, which brings us to finding the perimeter fairly easily now. So the lateral area is going to be 3 plus 4 plus 5 times the height being 3. So now we're in a position to find the surface area. 2b plus LA is equal to twice the base, so 2 times 6 plus the 36, and we end up with 48 square inches. Okay, let's take a gander here. This one's a lot more straightforward because instead of having to compartmentalize, all we have to do is plug and play. So I'm going to use the bottom formula. The surface area is equal to 2 pi r times r plus h. So we don't have to do this step by step. You just shove it all into the mix and mix it up. Okay. So 2 is given to us. Pi is given to us. We know what that is. R is my radius, so that's a 6 right there. Now, next is my radius again, And next is my height. And the height does not mean top to bottom. Height means the distance between the bases. In this case, 4, because it's at top to bottom. But in this case, it's between the bases. So we say, that's my height. I'll simplify a little bit and then plug it into my calculator. 120 pi centimeters squared. 376.99, but I used pi as the pi button on my calculator.